Okay, 5, 6 angle bisectors and perpendicular bisectors. We're going to use these in order to find distances and points on the bisectors. So you need to recall that a distance from a point to a line is a perpendicular segment. So you need to have that right angle, as you can see in this path right there, in order to make sure that it is a distance from a point to a line. When a point is the same distance from one line as it is from another, the word that we use is called equidistant. So angle bisector theorem, if a point on a bisector is on the bisector, then it is equidistant from the two sides of the angle. So looking at this, if I have this point B, it will be the same distance from the side AC as it will be from side AD. So the segment BC will be congruent to BD. Okay, so we're going to use this to find lengths. Use the information in the diagram to find the measure. First off, take note that I do have perpendicular and it's a bisector. So that means that AD will be congruent to CD. So if CD equals 16, then AD equals 16. Use the information in the diagram to find the measure EF. So now we're using a little bit of algebra. Again, I have perpendicular and I have angle bisector. So I know that EF equals FG. So x plus 1 equals 2x minus 1. I subtract x and add 1. So x equals 2. But it says find the measure of EF. So EF equals 2 plus 1, which is 3. A perpendicular bisector can be a ray, a line, a segment. It is perpendicular, and it goes through the midpoint of a segment. Remember that a midpoint splits a segment into two congruent parts. So the perpendicular bisector theorem states if a point is on the perpendicular bisector, then it is equidistant from the endpoints of the segment. So my endpoints A and B, I have perpendicular through a midpoint, so then AC equals BC. Use the diagram to find AB. So again, we're looking at what we have. We have perpendicular. It's through a midpoint since I have two congruent segments. So I know that AD equals AB. So 5x plus 12 equals 8x. Subtract 5x. And then divide by 3. So x equals 4. But it says find AB. AB is 8 times x, which is 4. So it would be 32. Trying the checkpoints. Went through and solved for x in all of them. And then I need to substitute in. And one consequence of the perpendicular bisector in a triangle, if I mark all of the, or draw all of the perpendicular bisectors, and I'm going to highlight them in red so that you can tell which ones are actually the perpendicular bisectors, because they don't draw them the whole way through. So they're in red. And I look at the point where they intersect. That point will be the same distance from each of the vertices. So the blue lines will all be equal. So where do the perpendicular bisectors of a triangle intersect? At a point that is equidistant from the vertices. Of the triangle. And your assignment is attached. Pay attention to questions 23 through 25, which will pertain to intersecting bisectors.